All right, guys. I'm going to talk about some word problems. I highly recommend that you do the word problems, or at least try them, before you watch this video. Right, you'll get more out of it that way. We'll have some more tomorrow in class during fifth period, to after our quiz to get ready. So we already talked about one a little bit, so I'm gonna not spend too long on it. And we're gonna mix and match with formats. I've already done the work, so I'm just gonna walk you through it. Okay, so we have this equation here with the height of the rocket is given by this equation 288t minus 16t squared, and the first question is, when does the rocket hit the ground? And we know on the ground that h is 0, right? So we're trying to find where h is 0. And we're trying to find for t, right? So we get some equation that looks like this, okay? A lot of us were challenged by this on the mid-year, okay? We're going to move everything to the left side, and so we're going to be left with 16t squared minus 288t. And the reason I do that, right, is because we like the coefficient of the square term to be positive, right? This guy's negative here, this guy's positive. That makes us a little bit happier. But we don't have to do that. Anyway, then it's a simple factoring problem where we factor out the 16t, so they share in common. And we're left with 16t times t minus 18 equals 0. We apply the zero product property twice to get to either t equals 0 or t equals 18. So these are the two instances where the rocket hits the ground, once at launch and then once 18 seconds later. Okay, so that's sort of the answer to part A. Part B, when we're trying to find how high the rocket goes, that's really asking, what is the vertex? What is the vertex? And we know, because this thing follows a parabolic shape, that it will be symmetrical. So we can use that to our advantage and say, oh, we're looking for the average of 0 and 18, which is, of course, 9. And so we know that it's going to occur between 0 and 18, or at 9 seconds. So all we have to do is simply plug in 9 into my original h equation, and we'll end up with 1296, right? That's, again, what we ended up with in class. And lastly, right, we're in this hot air balloon. We set this up in class, right? Where the hot air balloon is 720 feet above the ground, and we're trying to find out when the rocket gets that high, okay? And because it goes up to 1296 and starts at 0, we know it should probably get there twice, right? Once on the way up and once on the way down. So all we have to do is set 720 in for h over here in my original equation. I'm going to move everything to the left, and so I'll be left with this equation right here. Once you get there, you can decide how you do it. Do you want to factor? Do you want to use a quadratic formula? Or do you want to complete the square? I chose to factor, okay? And because it's an equation, I divided everything by 16 first, because every term there has a 16 in it, and I would like smaller numbers, not bigger numbers. So that gives me t squared minus 18t plus 45 equals 0. Much nicer numbers. And I was able to factor that into t minus 3 and t minus 15. Here are my sort of options over there in that box. And so that, by the zero product property, because two numbers times each other equals 0, told me that t equals 3 or t equals 15. Okay? And that makes sense, right? Because the rocket went up, it passed by the balloon here, and then it came back down. And it passed by the balloon again, right? And that makes sense. Okay. And you'll notice, right, those are also both 6 away from the vertex again, symmetry. Okay. Golfer standing on a hill. The golfer standing on a hill hits the ball so that the ball's position can be modeled by the equation y equals 15 plus 0.5x minus 0.002x squared. And the first thing I'm going to do is I'm going to rewrite it so that I have my 0.002x squared out front, right? Because we like our squared term, then our linear term, then our constant term. Okay. And so the first problem is very similar. Our first part is very similar to problem 1. How far away from the golfer does the ball hit the ground? So again, we're trying to find where y equals 0 this time. And so we get something that looks like this. And I don't like these decimals here, so instead of dividing by 0.002, I'm going to do the same thing. I'm going to multiply by negative 500. I know that seems kind of crazy, right, if we multiply by negative 500. But that thing is going to sort of undo everything. And so if I multiply by negative 500, you'll verify that I can get this nicer looking quadratic, right? x squared minus 250x minus 7500. Okay. And now this thing we could again try to factor, complete the square quadratic formula. I don't actually think it factors, so I use the quadratic formula, and you would have a calculator on your assessment if it looked like this. So here's my quadratic formula exercise where I said, oh look, negative b, that's positive 250, right? Because b here, a is 1, b is negative 250, and c is negative 7500. So negative b is positive 250, plus or minus the square root of b squared, 250 squared, minus 4 times 1 times negative 7500. That's 4ac all over 2. So then I'm going to play with what's in the square root. And again, if you want to try this out for yourself, pause me and do that. Okay, so I'm going to play with what's in the square root. These are just what those numbers are, right? 62,500 is 250 squared. And 30,000 is 4 times 7,500. Right? And then I add those together, I get 92,500. That is not a perfect square root, so I'm just going to use my calculator and go straight for this number, 304.14. That's the square root of 92,500. Okay, and then we get two answers. We get 277 and negative 27. And that actually makes sense because if you remember this problem, right, if we look at that function, the golfer's standing on a hill, so he's standing up here, and then he hits the ball. Okay, so it actually makes sense if we extended this back, right, we would get a negative answer. So that's good. That's good. Okay, so let's think now about part C, right? So this is sort of the answer we're looking for, 277.07. What does the 15 represent? Well, that represents the y-intercept, or how high the golfer is at the start. Oops, I did not do part B yet. Sorry. Part B, how high does the ball go at its peak? Again, we're trying to find a vertex. So we average these two numbers, and I get 125. Okay, 125 is the average of those two intercepts. So again, we're trying to find the vertex here, just like in problem 1. And all I have to do is I have to plug that in, right? I have to plug that in. And it turns out this point up here is 125, comma 46.25 or so. Okay, good. That's how we find the vertex, and we already said part C, right? 15 is the height of the hill that the golfer's standing on, where this thing starts, right? It's very similar to a problem we had in our binder. Okay, so I know that was kind of fast. I hope you pause me whenever you need to take something in. Okay, so let's again look at part 3. Okay, so part 3, Mr. Azak has who knows what kind of pet that has 600 of fencing to contain. And Mr. Azak wants to build a rectangular enclosure up against a stream so that he only needs to use fence for the other 3 sides. What's the maximum area of the enclosure he can build? So here's my beautiful stream. There's no fence up there. And we have something that looks like this, x, and y, right? Because we don't need the third side. I don't know that it's a square. It actually ends up that it's not. Okay. And we need an equation for the perimeter, okay? So we know that he has 600 feet of fence, so we can say that 2x plus y, or all the green sides, has to equal 600. Well, that means that y equals 600 minus 2x, right? If we just subtract 2x from both sides, we get y equals 600 minus 2x. And then we're ready to plug that into my area equation. Area equals x times y. So that yields this thing right here. If I plug in 600 minus 2x in for y, okay, you'll recognize that this ends up being a downward facing parabola because I'll have negative 2x times x, which is negative 2x squared, which is good because that means that the area is going to have a vertex that serves as its maximum. So all we need to do is find the vertex of this parabola right here that's circled in blue. So let's find its vertex. Okay, its vertex, right? We would find the y and the x-intercepts, and we would average them to find the x-coordinate of the vertex. So this is already factored, no need to FOIL it out. I'm either going to have x is 0 or 600 minus 2x is 0. That yields x is 300. And so these are my intercepts, my area equation. And then I just need to find the middle of them, where the vertex is at x equals 150, because that's the average of 0 and 300. And that will yield my vertex. Okay, so if x is 150, you can plug it into this guy up here, right? We'll get y equals 300, and then you multiply them to get this total area. That's my final answer. All right, I hope that was somewhat helpful. I'll try to go a little slower next time. I just done the work earlier, so I, you know, didn't want to do it out again. So again, hope you found this helpful. And I'll have some more word problems for us tomorrow after our quiz.